Hello everyone. So today we are going to solve this LeetCode problem, which is Trionic Array Part 2. Yesterday we have seen the part 1 of it. And what is Trionic Array is basically we would have an array which have been divided into three parts. First part is strictly increasing, second part is strictly decreasing, and third part is again strictly increasing. Okay, so in first part, what we had to do, we had to check whether our given array is trionic array or not. Okay, and we have to return the boolean value, which is if it is trionic array, we will return true, and if it is not, we will return false. But what this question says that we have been given an array nums of length n, and we have a trionic subarray in it. Okay, and trionic subarray is a contiguous subarray which follows this pattern, which is strictly increasing, then strictly decreasing, and then again strictly increasing. Okay, now what we have to return? We have to return the maximum sum of any trionic subarray in this nums. Okay, now we don't have to find whether this is a trionic array or not. We have to find a trionic subarray in this array, and we have to return the maximum sum of it. Okay. So what we'll do, we'll first see what are all the valid trionic subarray, and then what would be the second thing, that we'll take the sum of all these valid trionic subarray and we'll find the maximum sum among all these sums, and that would be our answer. Okay, and if there is no valid subarray, the result states negative. Okay, now what we'll do, we'll use our dynamic programming to solve this problem. Okay, how will you? We'll use four different DPs to track the phases of trionic pattern which are ending at index I. Okay, see, suppose first have been started 0 to I. Okay, this is the single element. Okay, this would be our base. Now what will we do? We'll have 1 to I. This will give us the strictly increasing phase. Okay, then dp of 2 and I would give us a strictly decreasing phase. Okay, and then again dp of 3 and I would give us again a strictly increasing phase. Okay, so this would represent our complete trionic subarray. Okay, so now let's see with the help of code how we'll do that. We have been given our nums array. Okay, what we'll do, we'll first take an variable to store the size of this nums array. Then what we'll do, we'll take a variable in which we'll take a negative value, which is approximately to the largest negative value. Okay, now we'll define our dp. Okay, our dp table, because our trionic subarray would be valid only if it has four indexes. Okay, because first two indexes would be increasing, second and third index would be strictly decreasing, then third and last index would be strictly increasing, because these three phases are important. Without these three phases we can't have our trionic subarray. Okay, okay, this creates our 2D dp table. Okay, then what we'll do, we'll initialize its first element with the nums of first element. That would be our base. Okay, and again a variable we'll take to store our answer. We'll initially take our answer equal to negative, which is infinitely smaller value. Then we'll start our iteration on our array. Okay, this is our code logic. We will process each element from left to right. Okay, we'll first reset our base state with our nums of I. Okay, so what will be our first case if our nums of I is greater than nums of I minus 1? Then what we'll do, we'll extend our increasing phase. Okay, first phase is increasing, that is first phase ith index, and it will have max of dp of 0 I minus 1 comma dp of first I minus 1, the maximum of these two plus our nums of I. Okay, this will start increasing from a fresh element or continue existing increasing sequence from the. Okay, now what we'll do in this if only, we'll check our second increasing phase. Okay, what would be it? It would be max of dp of 2 I minus 1 dp of 3 I minus 1 and plus our nums of I. Because if our upcoming element is greater than our previous element, it could be have been initial increasing phase or the third increasing phase. It would not be in our decreasing phase. Okay, so that we are checking over here. Okay, now case 2 would be if it is in our decreasing phase, that is our upcoming element is smaller than our previous element. Okay, is nums of I is smaller than nums of I minus 1. Then what we'll do, we'll extend our decreasing phase. Okay, which is dp of 2 and I, which is equals to max of dp of 1 I minus 1 comma dp of I minus 1 plus nums of I. Okay, so and at last this would be our decreasing phase. Okay, and at last what we'll update our answer, which is max of answer and our dp of 3 and I. Okay, and finally we'll return our answer. Okay, so this was how we have solved this problem. Okay, because every index knows which phase it is in. It would be an is either increasing phase, decreasing phase, or another increasing phase. Okay, and transitions are allowed only if the array direction matches. Okay, suppose it increases, decreases, and suppose it's constant, then we'll cut the loop here and start from the another index. Okay, because invalid transitions are blocked using a negative value. Okay, and what is the time complexity of it? It is O of n. Okay, so this was a solution, and if you have any doubt, just put it in the comment section or any suggestion, and